Python skill, we learned about all the important concepts we learned. Now today, the first class, we're going to start in the big data. So what exactly meaning of big data and how we are going to work in the big data, those things we are going to learn it. So today, first we'll start with the big data intro. So if you see today, whatever we are using applications, it may be Facebook is the one application, Google, Netflix, these all applications, whatever we are using, because of these all applications, within a given time, we are getting a lot of data we are getting. This lot of data we are not able to handle in our regular databases, like we have Azure SQL database, or we have Oracle SQL Server, MySQL, like these relational database management systems are available. RDBMS systems are available. Whenever your customer data you are not able to handle with RDBMS, then that data is called as big data. What is the big data? Big data is nothing but huge amount of data which cannot be stored or processed by traditional systems such as RDBMSs. RDBMS means like our Oracle, Azure SQL database, SQL Server, MySQL, these all things are RDBMS databases. So we need to define, okay, for a given customer, yes, I'm not able to handle in RDBMS means immediately we need to identify, okay, the data we are getting is big data. We need to go for somewhat higher systems. We have to go somewhat higher systems. Okay, that's how we'll define. Now, big data is also data, but with huge size. It's also data with huge size. There are also data only, but we have the more number of records will be there. Okay, because of the more number of records, more size, we are saying that as a big. And as it is a big, we are not able to handle using RDBMS, we are not able to handle. Okay, it is stated that almost 90% of today's data has been generated in the past few years. That's right. Because from the past few years only, we started using mobiles, smartphones, whatever it is, and more applications also we are using it, right? For small company you are taking also, they are using their own app. That much of technology is cheap and everyone is aware of the technology. So the reason from past few years only more data is generated. And just for our understanding, I given some kind of chart here. What do you mean by byte? What is size here? Kilobyte means, what do you mean by that? 1024 bytes it is. Megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, something like that I provide here. Okay, so this is what the size is. Generally, if you go and try to observe your normal relational databases, one table size if you observe, most of the cases you will see either in KBs or MBs or GBs. That's it. Okay, KBs and MBs and GBs. That's what we are going to see most of the case of RDBMS tables. Okay, now in case of big data also, we'll see most of them are GBs only, but there is a possibility some of things may go beyond that also. Okay, now on database means not only one table, right? It is a collection of tables. Altogether tables we are not able to manage in single RDBMS, then we go for the big data. Now to handle this big data, one more benefit also available. If you see categories of big data, we can handle structured data, unstructured data, semi-structured data. All three varieties of data we can able to handle. Whereas our regular RDBMS, if you take it, only structured data. Structure means rows and columns. If you are able to organize the data in the rows and columns, then it is called as structured. For example, EMP table, you take it. EMP number is one column. E-name is the second column. Salary is the third column. In that one, we are going to write the rows as 101, RAM, 3000. That is a one row. So we are able to organize the data, rows and columns. Whenever we are able to organize the data, rows and columns, that is called as structured data. Now, what do you mean by unstructured data then? Unstructured data is, suppose now I am speaking. Whatever I am speaking, if you record it, this is a one file, right? That file, can you organize as a rows and columns? No. Some video file, some audio file, some image file, okay, some log file, these all things are falls under unstructured data. Mission logs will be there. Mission logs will be there. Those are mission logs. Those things also will be falls under unstructured because we cannot organize the data as rows and columns. We cannot organize it. Something you're not able to organize rows and columns, then it's called as unstructured data. Now, what you mean by semi-structured data is it is intermediate. If you put some extra efforts, we can able to change as a structured maybe, but it's not ready to be structured. For example, XML file, JSON file. These all things are examples for semi-structured data. Semi-structured data. So now we know structured, unstructured, semi-structured. If anyone want more clarity, I request you people to go through the some Google or somewhere and learn some examples for structured, some examples for unstructured like that. And now coming to the point here, in our regular databases, RDBMS databases, what data you can handle? Only structured data. Only structured, that means rows and columns, only tables. Tables kind of thing you can able to handle in our regular databases. In the big data, what extra we are able to manage? We are able to manage not only structured, unstructured as well as semi-structured also you can able to handle. That is a benefit. That is a benefit. Now we have the characteristics here. Characteristics here. This is categories. This is the characteristics. So we have three V's are available. Each V is one V is variety of data. We can able to say big data means it may be available in the text format, sensor data format, legacy docs, image files, audio files, video files, you name it, whatever you want it. Any variety of data, we will be in a position to handle it. Any variety of data, we are in a position to handle it. Now, we have here next one that is called as velocity. As the people observed in the first screen itself, okay, nowadays data is coming from so many applications. In each 60 seconds, so too much of data is coming. That means velocity is too much. Velocity is too much because the data is coming from different applications. Okay. Next, size of the data, volume of data. As you know, volume of data also very big. Minimum it will come in the megabytes or gigabytes, something like that will be coming. Okay, we kbs, those all things are old days. Okay, nowadays in each second you may be generating the megabytes of data, we are generating it. So because of these all three characteristics, big data is very famous. It is able to handle any variety of data. Whatever velocity it is coming also it can able to handle. Then any volume of data also it can able to handle. Now, this is what the big data properties. Now I want a solution. I want a software. I want a software to handle the problem of any variety of data, any velocity of data, any volume of data, and it may be any categories of data like structured, unstructured, semi-structured, doesn't matter. So I want to handle this all things means I want one solution. That solution is big data. That solution is what? Big data. Now we have the clarity, we have the problem now. The problem is I need to handle variety of data, okay, volume of data, velocity of data. This is what the problem. These three things can be handled by new software. That new software is called as Hadoop. New software is called as Hadoop. What is your problem? Big data is the problem. So Hadoop is a solution. CRM is the problem. So solution is what? CRM means customer data, how to manage. CRM, customer relationship management. CRM is the problem. Then what is solutions are available in the market? Siebel CRM, Oracle CRM, Salesforce CRM, n number of things are available. ERP is the problem. ERP is the problem. Enterprise resource planning, manufacturing data. Okay, you have to manage HRMS data. You have to manage account payable data. You have to manage account receivables data. You have to manage. For that, for that is all is called as ERP. For that, we have the softwares in the market is Oracle ERP is available. SAP ERP is available. Like that, different softwares are available. Now you want to build the one website UI, user interface, you have to manage it. User interface, you have to create it. For that, we have the solution like React JS is available, Angular JS is available, something like that. So for each problem, some specific softwares are in the market. Some specific softwares are in the market. You want to do the data engineering, you want to do it, we have the ADF, Azure Data Factory, or Informatica, or Databricks, okay, or n number of things are available in the market. So you have the some problem, for that problem to satisfy, we have some softwares are available. Here also our problem is big data. Our problem is big data. And the big data characteristics are more volume of data, more velocity of data, more varieties of data, more varieties of data. These are the three characteristics or properties of big data. To handle that big data, we have the solution. The solution is what? The solution is
Hadoop.
what? Hadoop. Hadoop is the solution. Hadoop is what? It's a concept or it is a software?
Software.
Software.
Software, correct. Hadoop is the software. What is big data? It's a concept or software? It's a
Concept.
concept. It's a concept. CRM is a concept or a software?
Concept.
Salesforce is what? Concept or software?
Software.
Software. So there is a concept is available, there is a problem is available. For that problem to give a solution, we have the softwares are available in the market. Softwares are available in the market. Okay, now we have the Hadoop. Hadoop, if you go and try to observe, so we have traditional RDBMS versus Hadoop. Traditional RDBMS are failing, okay, because it has its own storage limit. People will be saying, as even we went for Azure SQL database sometime, right? In Azure SQL database, whenever we are creating it, clearly it's saying as 100 GB data, 100 TB data, something like that. We have the properties. More than that means you cannot handle. There is a limit, some certain limit is available in relational database management systems. Oracle has its own limit, SQL Server has its own limit, something like that. Now varieties, it can able to handle only structured data, tables and columns only, it can able to, columns and rows only, it can able to handle. Ultimately, only tables of data it can able to handle, not more than that one. Now, cost of the software. If you go for any of these things, we have the cost. Suppose if we want to maintain our data in the Oracle database, we have to purchase the Oracle software. If you want to manage this one in the SQL Server, you have to purchase SQL Server from the Microsoft. If you want to manage Redshift, Redshift you have to purchase from the Google. You want to manage in the Azure SQL database, that you have to purchase from the Microsoft. You name it, any software relational database, you have to purchase from some vendor and you have to use it. That means licensing cost is more for your project. Now processing type, we are able to process only one kind of data only are going to process it, and that too we don't have here parallel processing kind of concepts will not be there. Okay, we have to go in the serial mode, we have to go. Okay, that is the reason this also some problem. So there are some relational databases are available which supports the processing type is parallel, but however, most of the database processing type is serial. That means one after another, we have to send it. That is a problem. Next is cost of the hardware. Cost of the hardware also very costly. We have to use the blade servers, you have to use it. Because of the blade servers and all, the cost will be increased to the project. The source code, the managing the source code is not human readable. It is a mission readable kind of thing will be there. Meaning one file I given, let's say database file I given to your hand. The database file, you cannot open that one in the notepad or somewhere. Okay, that requires a specific software, and you have to open that one. The source code is that much of difficulty phase it is available. Whereas in Hadoop, there is no storage limit. Okay, you can, if your data is more, we are going to increase the our commodity hardware. We are going to increase. That means we are going to add one more CPU kind of thing. We are going to add it. And varieties, it can able to handle structured, unstructured, semi-structured, whatever you want. Cost of software is, it is open source, it's free. It is open source, it's free. There is no need to pay any 1 rupee also to any person. It is a open source. Because of this open source, everyone is showing too much of interest on this product. Processing type, it can do the serial, it can do the parallel also. Okay, but most of the times we'll do in parallel processing. Most of the times we'll do in parallel processing. Cost of the hardware, as I said, we are going to use normal CPUs. Normal CPUs. Let's say with 4 GB of the RAM, with 4 GB of the RAM. Okay, with 500 GB of the hard disk, we'll try to use as a server for our big data, our Hadoop. Suppose that 4 GB is not supporting, is speed is not good enough, then we'll add same kind of CPU, one more CPU are going to add it. We'll make these two things link up and we say as it's a cluster. This cluster has now two CPUs. If your data is still increasing, we'll add the third CPU also, we'll add it. Then our cluster is, which has the three CPUs now. Like that, whenever your business is growing, as business growing, we are going to keep on add the CPU after CPU, we keep on add it. Like that, we'll make the bunch of clusters, we are going to, sorry, bunch of CPUs will make as a cluster. Bunch of CPUs will make as a cluster. Now, source code is normal files. Your CSV files, we are going to manage internally. The files, we are, everything is file format. Everything is file format. In big data, everything in the back end, we are going to manage as a file format. As it is available, file format, it is very easy to manage. Okay. Now, history of the Hadoop, if you go and try to observe, okay, who invented this one, from where it came, those things, you can follow this document and you can read later. What is Hadoop? Now it is an open source project. Now it provides software framework and it is inspired by Google Map. Hadoop was originally written for search engine purpose. Hadoop is open source. It's just you try to read this one, you'll be able to understand. So this is what the ecosystem. Ecosystem means different softwares which are available in the Hadoop. The moment I say Hadoop, you need to know each and everything in this diagram, whatever you are seeing, at least you need to know base level, basic level. If you know basic level, each and everything, then we are good to go. First, we'll start with the something in the bottom we have here that is called as Hadoop Distributed File System, HDFS. What is that? HDFS. So everything internally we are going to store in the form of files. That is reason it's called as Hadoop Distributed File System. This is for storage. This is for what? Storage. Now we are storing the data. That's okay. We need to process it, right? That means I need to read the data. I need to insert some data. I need to update some data maybe. You want to do this all and these all things, then we required map reduce is required. Map reduce is for the purpose of, you can see these wheel symbols. Wheel symbols means what? Some processing purpose. Wherever you want to do some processing, we'll provide the wheel symbols. Wherever you want to do some storage, we'll provide the folder. Folder means what? What is the purpose of folder? To save some files. So here only two things I want to talk here. One is for storage, one is for process. One is for storage, one is for process. Storage purpose we are saying as HDFS. Process purpose we are saying as MapReduce. On top of MapReduce, we have the ARN is available. ARN means at another resource negotiator. At another resource negotiator. What is that meaning? We come to know down the line. And we have here these two things are main. These two things are main. These two things, if I want to communicate, means either I require some Java code, some Scala code, this kind of things. To overcome that kind of problems, we have these all ecosystems are available. Now we are not writing any codes, we are not writing here. Without writing code, Without writing code, we're able to access this HDFS and this map reduce things, we're able to access it. To do that one, easy of work purpose, we have the pig, we have the hive, we have the so many ecosystems we have here. As per our requirement, we are going to use them. Okay. Now, if you see the Hadoop architecture, this is what I was talking about. We have the user requested something. First, that will come to the master node. Master node will decides now, okay, for this work, we can do it. Who can do it? It will be decides here. It will assign the task to the slaves. Slaves is nothing but worker nodes. And in that worker nodes, the work will be happening. Okay, some reason, this worker node is very busy or it is failed. Immediately, this will be stopped and the work will be assigned to something else. Something else. That means 100%, 24/7, it will be live. There is no way to say, okay, system is down. Now servers are not working. That kind of situation is not there. Because at a time, all CPUs will not be down, right? Any one CPU is down also, nothing to worry. Using other CPUs, we can able to work on it. Today, whatever you are using, applications all are using backend cluster. For example, you are using the gmail.com. 24/7, 365 days it is on. Nowhere you see that, okay, Gmail is down like that, right? But backend CPUs are not going down. It will be going down. Sometimes hard disk failures may be there, RAM failures may be there, power shutdowns may be there, something problems may be there. But still, it is live because of this kind of architecture. We are going to manage different servers are available in the backend. One server is down also, we need not worry about it. Using other servers, we are able to manage it. Some reason this master itself is down. That's where we have here secondary master. Secondary master will do the same job of master. This secondary master is a backup for this master. Secondary master is a backup for this master. But secondary master, most of the times it will be in the sleep mode. Most of the times it will be sleep mode. Whenever this master is not working, then the secondary master will come here and try to do its job. The job of the master is assign the work to the slave nodes. The job of the master is assign the work to the slave nodes. Like it's a kind of project manager and team members. The project manager mostly he will understand the problem, then he'll try to identify the resource who can do it. He's going to give the work to that resource, right? Similar to that one, this master also will be doing it. Now, this is what the architecture. In the architecture, you come to understand here, there are master node, that is nothing but we call it as technically name node. Secondary master node, that technically called as SNN. Then slave nodes are called as data nodes or worker nodes. This is what the terminology. So master node is called as what? Master node is called as what? Name node. Secondary master node is called as what? SNN. Next,
SN.
we have here slaves are called as what? Data nodes or worker
Data.
nodes. Yeah. So whenever we are trying to start the servers, this kind of terminology we are going to see it. Okay, name node is started, data nodes are started, something like that. We are going to see the terminology. You will not see the terminology of master node is started, something like that. You see the terminology is name node is started, something like that. In all our log files, whenever suppose something is down, it is going to say, okay, name node is down, so and so data node is down, something like that is going to show the log files. So this terminology is mission terminology, name node, secondary name node, data nodes, these all are mission terminology. Our generic terminology, master node, secondary master node, slaves is our generic terminology. Now, coming to your Hadoop core components, if I say what are the main components in Hadoop means only two things. One is for storing the data, that is nothing but HDFS, Hadoop file system. Hadoop file system for the purpose of what it is? Store the data. We are going to store the data. Then MapReduce, this is for the purpose of processing the data. We want to read the data only top 10 rows. then MapReduce will be coming into the picture. We want to insert some data, then MapReduce will be coming into the picture. One is for storage, one is for process. Most of the clouds nowadays providing the bill also in two separate bills. They are providing how much storage, how much process you did it. Storage separate bill will be there, process separate bill will be there. Okay, if you have the databases which has the data inside that one, you are not deleted, even though you are not using it, it will be charged. You need to act on it and you have to delete those things. Okay, because we are going to have the storage also cost is there in the cloud. But these all things you are using internally in our CPUs. You are using, you are managing your own cluster, you are managing, then there is no need of any pay and all. Okay, but unnecessary data, don't store it, right? Try to delete it. So two things are available here. One is what? Storage purpose. Second is what? Processing purpose. One is
Processing.
storage, second is processing. Now we go for here, what is HDFS? What is HDFS? First we try to think about HDFS. HDFS is a highly fault tolerant distributed file system for data storage. Why it is fault tolerant? Because one CPU is down also, another CPU will be there, we can able to access that data. That is the reason 100% 24 by 7, 365 days, we can able to access that data. That's what it is, fault tolerant. Next is available, HDFS stores multiple copies of data on different data nodes or worker nodes. Multiple copies of data on different data nodes or worker nodes. Minimum is 3 copies. Minimum is 3 copies. That's how it will work. Meaning, suppose I have one resume is available. Our resume is available. I stored here. Your resume will be stored. Your resume will be stored not only in one CPU. It is going to store in 3 CPUs. Minimum is what? 3 replicas. 3 replicas it is going to maintain. That means 3 different CPUs. Your CV will be there. For some reason, one hardware is failure. Nothing to worry. We have still other 2 hardwares are available. We can able to get that one. One CPU is down, still you not worry about it. Using some other CPUs, we can able to get that one. So that is the reason we are storing the copy, multiple places are storing, minimum is 3 replicas. Now a file split up into blocks and stored across multiple data nodes by maintaining multiple copies of each block. So internally, it is going to divide the given file into blocks. Each block is stored in how many places? Each block is stored in how many places? 3 places. Now, we have here 2 versions are available in the Hadoop software. One is called as Hadoop 1.x. Second is called as Hadoop 2.x. Now, in Hadoop 2.x or more, each block size is 128 MB. In Hadoop 1.x, each block size is 64 MB. Okay. Now, Hadoop cluster typically has a single name node and number of data nodes. Okay, to form the HDFS cluster. That's what we saw, right? We have the single name node is there. That is what master node, and we have n number of slaves are available. Now, when a file is added to HDFS, it is split into blocks. This is the file 150 file we added, and this architecture is based on the Hadoop 1.x architecture. In Hadoop 1.x, each block size is 64 MB. This 150 MB is split into 64 plus 64 plus 22. Like there are 3 blocks, it is divided, and each block is going to be stored into minimum 3 times. It is going to store it. Every block is replicated 3 times by default. 3 times by default. That means this 64 MB block is going to store in the CP1, CP2, CP3. This also will be stored in the CP1, CP2, CP3, something like that. This also will be stored in the CP1, CP2, CP3 like that. Now, HDFS is fault tolerance because of this behavior. If you see, I have 4 blocks are available. One large file is available. The large file is divided into 4 blocks. Okay, now B1 is one place, B2 is in one place, B3 is one place, B4 in one place. Again, B1 will be available in some other place also available. Okay, each block is stored in different places, and each block is available 3 times. In this diagram, it is not clear that one. Each block is maintained how many times? 3 times. Same B1 will be available in the CPU also. Same B1 available in the CPU also, something like that. Some reason this B1, whatever we are seeing here, the CPU is down. First one, whatever available is down. Then what will happen? Suppose this is burned out. Then immediately we are trying to get that one from another places. We are getting, you see here, B2, B3, B1, B4. Same files, we are trying to get another combination. Because this combination of storage is failed now. Because it is burned out, so this combination of storage failed. So we are going for another combination of CPUs we are taking. In that way, 24/7, our servers will be up and working. Am I clear?
Yes, sir.
Okay.
Yes, sir.
Now we understand how we are storing the data. We understand. HDFS meaning what? How we are storing the data, we understand. Next is what do you mean by MapReduce? MapReduce is a programming model designed for processing large volumes of data. Here important word is processing is very important word. Processing large volumes of data in parallel by dividing the work into a sets of independent tasks. Internally it divides first, okay, it break down, okay, we have big program. It break down into small programs and try to process that one the parallel process. Now MapReduce is a process or program distributed processing of large data into cluster of nodes and all. So we'll try to see while you're doing it how it is distributing, how those things we'll try to see it. Theoretically, if you read it, it may not make more sense. All you need to understand is we have only two core components are available here. One is called as HDFS, second is called as MapReduce. While you're doing this the work, actually we come to know more sense of each component. Now some questions theoretically I have here. Let's try to see which of the below can be considered as characteristics of big data. What is the correct answer?
All of the above.
All the above.
All the above. Hadoop is the solution for big data problem.
True.
True.
Yeah,
True.
true. Hadoop follows distributed parallel processing mechanism to process the big data.
True.
True. Next, which of the below in traditional RDBMS lead to the evolution of Hadoop? Storage limit is the problem, parallel processing is the problem, open source is the
All of
problem.
the above.
All of
Yeah,
above.
all of the above. What is the default block size in Hadoop 2.x? What is the default block size in Hadoop 2.x?
128.
128
One
MB. Correct.
128 MB.
Which is a master node in Hadoop?
Name node.
Name node.
Name node.
Name node. Next, into how many blocks a file 260 MB will be divided into in Hadoop 2.x? How many blocks? 260 in Hadoop 2.x. If you
Three
divide
blocks. Three
3
blocks.
blocks, 128
Three
plus
blocks.
128 is 256. Then remaining 4 is another block, third block. So it is 3 blocks. So C, option is C. Is Hadoop fault tolerant? True.
True.
It is fault tolerant. Select a Hadoop distribution from below. Yeah, now what is the Hadoop distribution is? Hadoop is a software, that's okay. But problem is it's not like um, MS Office. If you install it, you'll get the Excel, PowerPoint. Okay, we'll get the MS Word. These all things we are getting, right? MS Office is what here distribution I can say. MS Office is what? Distribution. If you install MS Office, internally that has what? Internal that has Excel software, MS Word software, PowerPoint software. Even we have the access, those all other softwares also available. So how the MS Office is a distribution? If you install MS Office, how you are getting Excel, PowerPoint, MS Word, something like that. Similarly, Hadoop is a distribution. Hadoop means not a single software. MS Office means it's not a single software. Internally, it has what? So many components, so many components.
So many
Similarly,
com-
Hadoop also has so many components. We have to do lot of integrations, lot of configurations, those all things. Okay. If the Microsoft is not given MS Office software, they give an Excel separately, PowerPoint separately, MS Word separately, then you have to install three things separately you have to install. Once you installed it, you may require the integration also. Sometimes I will be keeping Excel, I will be keeping in the PowerPoint. Then I require integration. Those all integrations also you have to do manually. So what Microsoft did is they are saying as a man, don't install one by one. You install Office, it will do the installation of all the components and also will do the required configurations also for you. Similar concept is here. You go for Cloudera Hadoop. If you install the Cloudera Hadoop, you do not worry about internally Java I need to install. Okay, I need to install the Scala, I need to install, or I need to install the Python, I need to install, or I need to install the Scoop or Hive. These all things you not worry about it. Whatever ecosystems I shown in the top diagram, Scoop, Hive, HDFS, MapReduce, those all things I shown, right? Those all things, whatever you required for the Hadoop, everything is packaged. Everything is packaged as a Cloudera, and they're giving it. Here, Cloudera you can compare with the MS Office. Cloudera you can compare with what? MS Office. If you install the Cloudera, we'll get the HDFS, we'll get the MapReduce, we'll get the Hive, we'll get the Pig, we'll get the everything. You got my point? As
Yes, sir.
usual in the market, same job will be doing by other people also. So other people are available, Hortonworks and Mapper. These three are providing Hadoop as a package. Hadoop as a package. Any of one thing you can download and you can install it, you'll get all the big data required solution, you are going to get it. And what is the benefit of, again, this is free. This is also free. Again, what is the benefit for them to give these all things free of cost to you, right? So each one has their own cloud also they have it. Some people will be saying as, okay man, hardware also I don't want to maintain in my places. You maintain hardware in your place only. Then yes, they will be providing simply one URL to you. Using that URL, you are going to start working on it. There is no headache of hardware. There is no headache of software. It's like how we are using the Google Drive. Google Drive you are using, you are least bothered about what is the hardware, what is the software in the back end. You want to store something, you are putting in the Google Drive. That's it. You are using it, just you are using it. Similarly, each provider has its own cloud is available. Okay, that's where they're going to get the benefit. Now, Hadoop distributions are now, I can say as what? All the above. All the above are Hadoop distributions. In our training room, what we are going to use is, we are going to use Cloudera distribution, we are going to use it. In our training room, what distribution we are going to use? Cloudera. Even the market share also, if you go and try to Google it, market share of big data among these three things, if you Google it, you see the more percentage will be towards Cloudera. More projects are going on in the big data on the Cloudera distribution only it is going on. That is the reason we choose in Cloudera for the training room. Okay, the answer is for this one, all the above. I given here answers also in the order. Okay, you can see this one and you can match with your answers. This is about the introduction, how we can do the big data, how you can handle using Hadoop. Okay.